Reading temperature with a Do-more PLC is easy. In fact, this is all the code you need right here. Don't see any? Me neither. There isn't any. You don't have to write a single line of code to get the temperature values with a Do-more PLC. You'll have to write code to use the temperature, of course, but once you configure the temperature modules, the temperature values just appear ready for you to use. Easy. In this example, we have a Do-more PLC connected to 2 thermocouples, 2 RTDs, and 3 different types of temperature transmitters: a sensor head-mounted transmitter, an integral transmitter, and a fixed DIN rail-mounted transmitter. Here's what it looks like on a test rack. Here's the Do-more PLC, here's the 2 thermocouples, the 2 RTDs, and the 3 different types of temperature transmitters. They're wired exactly like the block diagram shows. The sensor wire shields are grounded only at the sensor end. If you ground the shield at both ends, you've just created another current path which can cause ground loops and actually make things worse than having no ground at all. So be careful only to ground sensor shields at one end. The thermocouples use the special thermocouple DIN rail terminal blocks. These ensure continuity of the special thermocouple wire by clamping the wires together instead of connecting them through a terminal block, which would create unwanted thermocouple junctions. To configure the thermocouple module, you just move some jumpers. Select the number of channels you're using with these first 2 jumpers. We're using 2 channels, so we only want a jumper on terminal 1, exactly like you see here. The thermocouple module supports all kinds of sensors, and it can even be used as a 5-volt or 156 millivolt analog input. We have type J thermocouples, so it looks like we need all 4 jumpers installed, and we do, so we're good to go. The last 2 jumpers select the units: degrees C, degrees F, and you can select whether you want the result to be signed or 2's complement, which some systems require. We have this one set for 2's complement degrees F. Now we're only using 2 of the 4 channels here, and since these channels measure extremely small voltages, it's easy for them to pick up stray signals from electrical noise when they're not connected. So make sure you jumper any unused channels to keep your system as electrically clean as possible. Well, that's it for thermocouple module. Let's look at the RTD module. The RTD module uses the same jumper settings for the number of channels. No jumpers is 1 channel, this jumper adds 1 channel, this jumper adds 2 channels. We're using 2 channels total, so we need to add 1 by putting a jumper in this slot here. The RTD module supports all of these RTDs, and we're using PT100s, so we need these 2 jumpers installed, just like you see here. The unit selection is just like the thermocouple module, and again, we have it set for 2's complement, degrees F. Finally, we're using an analog input card to read the 4 to 20 milliamp signals from the 3 temperature transmitters. And it has a similar jumper selection setup. We're using 3 channels, so we need to add the jumper that adds 2 channels. Perfect. Well, the modules are all configured, so let's look at the software. As we mentioned earlier, you don't have to write any code to get the temperature values once the modules are configured. The cool thing about the Do-more Designer software is when you connect to the Do-more PLC, it automatically identifies all the modules you have plugged in and assigns memory locations for the results. We see that under the System Configuration, I/O Mappings. Here we see the analog card has 8 status bits we can read and 8 analog values we can read. The thermocouple and RTD modules are the same, except they have 4 status bits and 4 analog values, 1 for each channel. All of the details about these module status bits and mappings and configuration is in the Do-more hardware manual, which is a free download. That's important. Don't go looking in the individual module specs or manuals. Those are maintained for the older legacy processors, not the Do-more. Everything you need to know about connecting a module to the Do-more is in the Do-more hardware manual. Here's a data view showing us all the thermocouple and RTD values. These values have an implied decimal point. If we put a cup of cold water on one of the probes and hot water on the other, we see the values change. Exactly what we expect. If we add the temperature transmitter values to the data view, we can see that the results aren't in degrees F. Remember, the analog card takes 4 to 20 milliamps in and converts that to a number in the range of 0 to 4095. Wouldn't it be great if we could get the corresponding number in degrees F? Well, the cool thing about the Do-more is it has this scale function, and it does exactly that. We just specify the input range and the range we want that to correspond to, in this case 0 to 100 degrees F, and put that result into a real memory type, and we're done. Now, if we watch these real values in the data view, we get the actual temperature values with decimal point in everything, which makes writing your ladder code much easier. I have a Seymour HMI monitoring all of those values. If we swap the probes, we see the results graphically. Perfect. And if we disconnect one of the wires, the indicator that's monitoring the status bit provided by the temperature modules lights up, so I instantly know there's an issue with the wiring of the sensor. Awesome. And again, we didn't have to write one line of ladder code to get these temperature values, though we did add a scale function to make things a little easier to work with. If you have any questions or need any help, please don't hesitate to contact Automation Direct's free, award-winning tech support during regular business hours. They'll be happy to help. And don't forget the forums. There are lots of folks there that love to share their years of experience. Just don't post any support questions there. Automation Direct support staff doesn't monitor the forums on a regular basis.